Hey guys, today we're going to do stoichiometry again. We're doing mass to mass, practice sheet number 3, problem number 1. So let's go ahead and start talking about this. And one thing that I want to stress with this is that we have a bunch of steps that we have right here that you need to make sure that you follow these steps. It will help you out. And if you write everything else out, it'll help you out. Okay, remember that if you have it there and you label it, you will know what we're talking, and I'll know what you're talking about. You'll know what you're talking about. You won't forget it. So let's go ahead and do the first problem. Our first problem is in the combustion of carbon monoxide, what mass of carbon monoxide is required to produce 0.69 grams of carbon dioxide? The unbalanced word equation is carbon monoxide plus oxygen produces carbon dioxide. Now, again, these are type 3 compounds that are here, carbon monoxide. And one thing about that is that we just go ahead when we write them out, all we have to do is write down what it says with the prefix. If there's no prefix, that means that there's only one of them. But remember that that's only on the first element. The second element, there would be a mono for only one, like we have on this one right here. So we have carbon monoxide. Okay. And we're going to go ahead and bring that down just a little bit. So I have carbon monoxide plus oxygen, okay, which is O. And that's going to yield carbon dioxide, so 1 carbon and 2 oxygens. Now we do have a couple of issues here. I have an element by itself. And what is my rule when there's an element by itself? Well, that is we have to say, is that element diatomic? So we have to determine whether or not the element is diatomic. How do we do that? Well, there are only seven diatomic elements. So what we have to do is we have to determine if it's one of those 7. Now, again, we're going to click on our periodic table. I'm going to increase this just a little bit here. And we have oxygen right here. Well, our 7 diatomic elements make a 7 on the periodic table plus hydrogen. So it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine. There's 6 plus hydrogen is 7. So oxygen is one of our diatomic elements. So we're going to go back to our question. Oops, so you're back to this right here. So we know that this right here is diatomic. So we have to put a 2 there. So now we have to go ahead and balance this this equation. So we're going to go ahead and balance it. Okay, and so we're going to just scroll down here a little bit. We have carbon, and we have oxygen. On this side right here, I have 1 carbon. You see 1 carbon. And then we have carbon on this side. And over here, we have 3 oxygens. I'm going to put a 3 in there. And then on this side, we have oxygen. And we only have 2 oxygens on this side. And we have 1 oxygen right, or 1 carbon right there. So we're going to put down 1. So we don't start off with carbon, we're going to start with oxygen. Now here's the unique thing, because oxygen on this side, if I change that number right here, we have to just make it even. So that's how we're going to do, is we're going to make it even. And the reason is because I can only have even numbers of oxygen on this side. So that means this side has to be even. The easiest way to make this even is to put a coefficient 2 here. Remember, we can change the coefficients, but we can't change the subscripts. So this means now I have 2 carbons, but now I have 4 oxygens. And we're just going to kind of get rid of these. Okay. And just highlight them to know that they're gone. Okay. So now I'm going to chase the carbon over on this side. So now the only way I can make this 2 carbons is by putting a coefficient 2 there, which changes that to a 2. But it also changes my oxygen to say that I have O2 twice, so it changes that to a 4. And again, we'll get rid of this. And my suggestion is you always show your work. Again, show it all, it's there. Now we have our balanced equation. So if I was going to do a molar ratio for this, I would have, I would have 2 to 1 to 2, and there's my molar ratio. Okay, and again, I always like to make sure that you have it there. You don't have to label it because I will see that as a ratio, but if you did, so our molar ratio is that. Now, once we have our molar ratio, now we can go ahead and start off with the problem and the number that's in the problem and do our stoichiometry. So we know what our center part is, okay, using our stoichiometry map. And like what I said before, using our stoichiometry map, if we go back down to that, that is something that it's nice to go ahead and know that you have. So here's our stoichiometry map. We've gone from mass to moles and then back to mass. Now again, in order to get to moles, we have to use this right here. We're going to use the molar mass in grams of the compound that we're talking about with the number of moles, okay, that it's equal to is 1 mole. And then we're going to use our molar ratio right here in the center. So we're going to put whatever we start off with, the compound that we started with, the coefficient there, and then the coefficient for the number of moles for the one that we're going to. So let's go back to the problem. And here's our problem. And let's go look at the question. The question says, I have, what is the mass of carbon monoxide required to produce this much carbon dioxide? So I'm going from here to there. So my molar ratio is going to be 2 to 2, which is a good thing, which I don't have to do the math in. So let's go ahead and start off, and we're going to have 0.69 grams of carbon dioxide, which is CO2. We're always going to do our conversion, our times and a line. And remember that we're going to put moles on top and molar mass on bottom. So we know that the molar mass of carbon dioxide equals 1 mole of CO2. And if I go down to the bottom, I know that I'm going to have our grams of carbon dioxide, which if I did it in my head, and we said at this point, the molar mass could be a little bit different. So we know that we have 1 carbon at 14 plus 2 oxygens at 16 each, which is 32. So we're going to add 32 to that. That equals 46. So we know that down here we're going to have 46 grams of CO2. Now, one thing that I like to make sure is, let's double check the math on that. So we have 1 carbon, 14 plus 16 equals 46, and so we're good. So now we can get rid of something. We're in grams of carbon dioxide. Okay, so I'm just going to pull this over here so we can still see. So we're going to get rid of that, and we're going to get rid of this one over here, 2 grams of that. Okay, so we got rid of those 2 right here. We're left with moles. Now we have to go back to our stoichiometry map, and now we have to do our molar ratio right here. So we put the coefficient with the compound A that we started with on bottom. And there's a reason why, because we have to get rid of that A. So if I go back to the question, I have moles of carbon dioxide here. So we're going to put moles of carbon dioxide down here, but it's going to be 2 moles, because that's what I have is 2 moles of carbon dioxide. So we're going to put down here 2 moles of CO2, and on the top we're going to put, what are we going to? Well, we're asking for the mass of carbon monoxide, and so we're going to put this up on top. So we're going to put down here 2 moles of carbon monoxide. Okay, now I can underline this, and I like to underline this over here too. Okay, and now what I have to do is I have to convert that, or we're going to convert moles of carbon monoxide to grams, but let's go ahead and get rid of this here, because that would be a good step to get rid of that too, because now I have, it shows me that I have it in moles of carbon monoxide. So if I go back to my stoichiometry map, if I have it in moles, now I have to use this. So I'm going to put my moles on the bottom and my molar mass in grams on the top. So, and again, what that shows us is we cancel it down. So 1 mole of carbon monoxide equals how many grams of carbon monoxide? Well, the easiest way to do that is to go ahead and say I have 1 carbon at 12 plus 1 oxygen at 16 equals 28. Now that's going to be 28 grams of CO. Now I'm going to go back and double check this because I think I made a mistake. Now, I always do this, and I want to do this before. So let's go, because I think that I might have put nitrogen in there, but let's see if I did. So carbon, there's 1 carbon at 12 plus 2 oxygens at 32 equals 44, and I did. I made the mistake of putting it in there. So that was a good catch. Now again, that would just throw everything off. You'd still get points for it, but let's make sure we try to do it right. So we're going to go ahead and underline this. Okay, and that's going to equal grams of carbon monoxide, because I'm going to have my moles of this are going to be gone. So we're going to get rid of moles, and they're gone. So I'm left with grams of carbon monoxide. So now all I have to do is figure out what that is. Okay, so all I have to do is our math. So we're going to take this number right here, and we multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. Now, here's one other thing I'm going to do. I have a 2 up here and a 2 down here. So I'm going to get rid of that. So I'm going to get rid of that a little bit darker. Okay, and the reason is because I don't need, it's over top of itself. I could also get rid of this one right here if I wanted to, and this one. Okay, so now all I have to do is take this number, divide by 44, multiply by 28, and I'll come up with my answer right here. So let's go ahead and do the math. And it says 0.69 divided by 44 and multiply by 28. That's going to equal 0.439. So I'm going to put that in there. I'm going to put down 0.4390, I believe it was. So let's go back and look at it. And it was a 0. Okay, so that's what that equals. Okay, but we have to have it in the correct number of significant figures. So I go over here and I look at it, and there's 2 numbers and a 0. This 0 is the only thing we have to worry about. The other 2 are significant. So our 0s at the beginning is significant. If you go back and look at the rules say that preceding zeros are never significant. So we don't count that one, so our answer needs to be in 2 significant figures. So we put our line right here. We look at the number after the line. That number right there says we round up. So I get rid of those and round up to that right there. And that would be our final answer. So there we go. That's what we would have for our mass of carbon monoxide that would be required if we had a complete reaction with yielding 0.69 grams of carbon dioxide. So we'd have to at least start off with this amount. So there we go for question number 1 on stoichiometry practice number 3. Hey, as always, go Mohawks. Nelson out.